Good morning or good afternoon, depending on where you are. And thank you for joining this talk. And thanks to the organizers for inviting me. This is actually my first keynote, so I'm very glad to give it at Maltese. So before going to the core of the keynote, I wanted to tell you something about me, just a couple of minutes. So I'm currently associate professor at the Software Institute at the Università della Svizzera Italiana. This is located in Lugano, and you can see here some of my colleagues. I'm sure you know many of them. And Lugano is a small city in the south of Switzerland. It's very close to the Italian border. And what I do there is basically to lead my research group that is called CERT, and is composed by these amazing guys. I have as of now 3 postdocs and 6 PhD students. And we work mostly on software maintenance and evolution with a focus on recommender systems for software developers. I will tell you a little bit more about what we are doing right now at the end of the keynote. And I started my PhD in 2010, and ICSM 2010 was my first conference. This was in Timisoara, and it was amazing, a lot of food. And as you can see from my face here, probably I was getting a question that I didn't understand. So I hope today it will be different. And why I'm showing you this conference? Well, because what I realized is that as a PhD student, conferences for me were very important, especially because I had the opportunity to talk to more senior researchers, right? And to basically gain some pieces of knowledge from them, especially during coffee breaks. And what I realized is that PhD students who started their PhD the last year or this year basically didn't have this opportunity, right? I know that organizers of virtual conferences are doing their best, are doing a terrific job to push the social interaction, but I think we all know that it's not exactly the same, right? So what I decided to do when I got the invitation to give this keynote was basically to, let's say, dedicate my first keynote to PhD students, or in general to young researchers. How? Well, what I did was basically to look back in the last 10 years, that is basically my whole career, and I tried to look at the articles that I published in the field of software quality to understand what are the 2-3 lessons learned that I think is important to share with younger researchers. And to check basically also how my research changed over these 10 years. So this keynote will basically be about my experience in this field and what I learned and what I would like to share with the PhD students, or in general, young researchers. And the focus, the topic of the keynote will be empirical software quality, and this will be organized into 3 parts. So I will start by talking about the evaluation of tools to automatically improve code quality, like, for example, refactoring recommenders or tools to automatically improve the readability of code. Then we will move to empirical studies on software quality, and I will tell you my experience in replicating a study that I did almost 10 years ago. And finally, I will have a very short parenthesis about what we are doing right now in my research group. These are research directions on which basically I don't have any result. I just want to share with you some ideas and maybe to get some feedback, or just to give you possible ideas for future research. So let me start with the first part, okay, evaluating tools to improve code quality. So I did my PhD on software refactoring. This was the cover of my thesis, and what I did was basically to propose approaches to recommend refactoring solutions, okay? So the idea is that you have a very large class, for example, a God class, and you want to refactor it. How? By extracting, for example, smaller, highly cohesive classes from this large class. The problem that you have is that if this class is really big, like more than 100 methods, for example, well, you need to manually check these methods to understand which ones can be grouped together in a new class to extract, right? So if you have a semi-automated approach that basically tells you these methods are likely to be good candidates to be extracted in a new class, you can basically save time, right? And this is basically what I did. And when I started my PhD, most of these approaches were supporting refactoring by mostly using structural information from code. What does it mean? That you want to understand automatically what are, for example, the methods in the God class that are good candidates to be extracted in a new class, right? And what you can do is to perform some static analysis and say, for example, okay, if 2 methods share the same attribute of the class, so they both use the same attribute of this class, probably they are good candidates to be grouped together in a newly extracted class because they are related to each other. Or if they invoke each other, right? Probably they collaborate in the implementation of a feature. The whole idea behind my PhD was, can we recommend better refactoring if we combine this structural information with semantic information? What does it mean? It means that you look at the terms present in comments and identifiers of the source code, and you try to understand if, for example, two methods talk about similar things. If you look at the two methods in this slide, you can see that they talk about users, database, connection. So they both talk about the management of users in the database, right? So you can understand that they have certain relationship. So this is what I did in my PhD. I proposed refactoring approaches that use these two sources of information. And the first approach that I developed was an approach for X-class refactoring. Now, I don't need to go into the details. This is basically everything you need to know to understand what I'm going to say now. I just wanted to give you a little bit of context that was needed, okay? So when you create an approach that automatically improves code quality, what you have to do is basically to answer a very important question if you want to get it published. That is, does it work? So in other words, you need to empirically validate your tool, your approach. And you should know that I was the first student in the research group in which I did the PhD that was working on this topic. So we didn't have a strong expertise on how to evaluate these tools, these refactoring recommender systems, basically. So what do you do in this case? Well, what I did was to have a look at the literature, right? And in particular, what I did was to have a look to articles published in top venues, what are considered, let's say, top venues, to understand how other researchers validated these tools to automatically improve code quality. Keep in mind that I'm talking about the time period going more or less between the 2000 and 2009. Okay, so we are talking about almost 20 years ago. What I found, of course, there were many different study designs that were applied by different researchers, but what I found is that there were some papers published in top venues in which the evaluation was mainly based on quality metrics, okay? So what I thought was, so first of all, what does it mean, evaluated on quality metrics? It means that you take the code before the refactoring, you use your approach to recommend refactoring solutions, you implement these refactorings, and then what you do is to compute some quality metrics before and after the refactoring to see basically whether your system improved or not in terms of quality after you implemented the refactorings that your approach recommended. So I looked at this evaluation and I say, well, you know, does not look very challenging to me. It looks kind of cheap in terms of research effort. And if these other researchers managed to publish in top venues with this evaluation, I'll try to do the same, okay? I'll be back on this point, it's an important point. But basically, this is what I did. I ran my study, I got some results, the results were good. Again, we don't need to go into details, it's not important. So what do? You write your approach, you write your study, you put everything together, you submit the paper, right? And I got this paper rejected. And in particular, this was one of the negative comments that I got by one of the reviewers that basically was complaining about the improper validation. Why? Because the reviewer was saying that the validation, the metrics that I used for the evaluation were never guaranteed to be good proxies for good design, for high quality code, okay? And I mean, I already agreed with this reviewer when I got this piece of review. I think it was 100% right. But I agree today even more with this reviewer. So what do you do when you get a paper rejected? So the reaction was, of course, let's try to understand how we can improve, right? And since most of the criticisms were on the empirical validation, what we did was to think about how we could improve the validation. And we came up with this idea of evaluating the approach by using historical information. What does it mean? It means that you basically analyze the history of the system, you try to identify refactorings performed by developers, then you have the code before and after the refactoring performed by the developers, you run your approach on the code before, you get a refactoring solution, and you can compare the refactoring solution proposed by your approach with the refactoring implemented by the developers. If it's very similar, you can say, okay, the approach recommended by the refactoring recommended by my approach was meaningful. okay? So this is what we did. Again, results were quite okay. We added this evaluation on top of the one that we already performed. We submitted that paper to a different venue, and we got it rejected. And we had one of the reviewers who was complaining about this additional validation that we put there, the one based on historical information. His point, or her point, of course we don't know, was that we could not know what were the reasons behind the refactoring performed by the developers, nor if it was performed with an automated tool. Okay, so basically we could not know if, for example, we were evaluating the quality of a refactoring recommended by our approach by using the output of another automated tool as Oracle. Okay, and the long story short, this reviewer said you must involve developers to assess the meaningfulness of the refactorings recommended by your approach. Now, I have to say that still nowadays I don't agree 100% with this reviewer, but he had a good point, the point of you need feedback from developers, okay? So we didn't have access to developers at that time. So what do you do in these cases? Well, what we did was to run a study with computer science students, master students, okay? Some of them were working in industry. We got some feedback about the meaningfulness of the recommended refactorings. We got, again, some good results. We added this evaluation on top of the previous two. We resubmit the paper to another venue. And after some round of revisions, we eventually got this paper accepted. And we still got some feedback saying, you know what, your study with students is not very realistic. Why? Because you are basically asking students to assess the meaningfulness of refactoring operations that you are generating on open source systems that they didn't write, right? So they don't have a strong expertise to tell you this validation is good, this recommendation is good or not. So why I told you this whole story, right? It's not to show you how the validation improved or things like that. So first of all, this story that I told you in, I think, 7-8 minutes lasted 2 years. Okay, so these were basically 2 years of my PhD. But these 2 years were not wasted time, of course, because thanks to these reviewers and to the feedback that I got, I learned how to properly validate a refactoring recommender. So this is the first point, right? But the second point, and this is the main message that I want to give with this story to young researchers, is to don't go cheap on research. And what I mean with that is the following. When I had a look at the literature to say, okay, let me see how I can validate my refactoring recommenders, I found, of course, many different types of empirical studies, right? But since I found that some researchers managed to publish in top venues by only using the validation based on quality metrics, I said, well, you know what, I could do the same. I could get also a publication in a top venue. So I didn't think in terms of, I want to get the best research possible out of this work, but I thought in terms of, okay, I'm going to get in a fast way a top publication, okay, which was my goal as a first-year PhD student. But as you have seen, my plan was to save time. At the end, I spent 2 years that, as I said, were not wasted because I learned a lot, but still 2 years to publish, right? So even if you find some papers that are published in top venues, this does not mean that these papers are perfect, okay? And because there are no perfect papers, basically. And if you look at the literature nowadays, another concrete example that I can give you is, for example, for deep learning models that generate text. For example, we have many great papers presenting approaches to generate code comments using deep learning models, right? Now, there are some of these works that evaluate their approach by only using some metrics, like, for example, the BLEU score. And they say, my approach is 2% better in terms of BLEU score than the baseline. Okay, but what does this say in terms of the quality of the comments that are generated by your approach? So when talking about code quality, I think it's really important that we combine quantitative and qualitative research to really understand what's going on, okay? So this is the first point, the first message. The second one is that as a PhD student, I felt a lot the pressure of publishing in top venues. Okay, I think this is unfortunately quite normal. But what I realized later on is that, you know, as a PhD student, you tend to compare with others. And this is completely wrong because every PhD is different from another, but also because sometimes you can look at the CV of a person and say, oh, that guy managed to publish, I don't know, 10xc, 5xc, whatever it is, or FSC, whatever it's important for you. But what you cannot see is basically the path that led there. And if, for example, you have the chance to have a look to my publications in the first 2 years of my PhD, these were my publications in the top ranks, basically 0 publications. Okay, I got some rejections, but I didn't manage to publish in top ranks. Why? Because it takes time, and you must learn how to create a solid piece of research. And the last point for this first part, then I will move to the second one, is that as a community working on code quality, I think we should be very proud of what we are doing, because I had a look at some recent papers published in the area, like in 2020. And, you know, if I compare the evaluation that they performed with what I used to do 10 years ago, my validations look like a joke, okay? So one concrete example, if you look at this paper, very nice paper published on TSC, and if you look at the validation that they perform, they go to companies, they ask feedback from developers. I mean, it's much, much better. And I think this is due to the community work, right? To the fact that we are improving year after year our empirical standards. So I think we should be proud of what we are doing from that perspective. So this was my first thought, okay? Now let's move to the second one, that is about empirical studies on code quality. And it's about what I learned by replicating a study that I did almost 10 years ago. In particular, in 2012, I published this work at SCAM, and this was the first work investigating the relationship between refactorings and bugs. In other words, we tried to understand to what extent refactoring operations induce bugs. Now, the right terms to use here is induce, because we use the SSZ algorithm, but to simplify, I'm going to use introduce bugs, okay? Even if it's not correct. So I don't have time to explain to you the whole experimental design, but to give you an idea about what we did. So we basically mined refactoring operations performed between subsequent releases of 3 open source projects. So we had 63 subsequent releases overall. So it means you have release 1 to release 2, release 2 to release 3, and so on. And for each of these pairs, we used a tool that was named RefFinder to identify refactorings performed between these 2 releases, okay? Keep in mind that this is a very important point. We knew that the refactoring was performed between these 2 releases. We didn't know in which commit it was performed, okay? For example, in the slide, I only know that a move method was performed on file fj between release 1 and release 2. Then we use this SSZ algorithm, that is an algorithm that takes as input a bug fixing commit and tells you in which commits this bug has been likely introduced, okay? So we identify we use this algorithm, to identify commits in which bugs have been introduced between these 2 releases. And then we have this strong assumption saying, okay, if one of the refactorings that we detected impact the same file that is also impacted in a bug introducing commit, then I assume that the refactoring introduced the bug. Now, you can understand where is the problem here, that we didn't have any guarantee about the fact that the refactoring was introduced in the bug introducing commit. We only knew that it was performed between these 2 releases. We didn't know in which commit, okay? So this was a very strong assumption that, of course, is explained in the paper and everything. But as an author, I always thought, well, I must replicate this study because I want to see if my findings that have been obtained with this experimental design, with this strong assumption, still hold, right? So when Massimiliano Di Penta visited me for his sabbatical the last year, we decided to perform a differentiated replication of our own work, okay? In order to address all the issues that we had in the original experimental design. So again, I don't have time to go into details, but to give you an idea, these were the main points that we tried to address. We detected refactorings at commit level, not at release level as we did in the original study. We used a more precise tool, a tool that scales, that can be run on non-compiled code, that is RefMiner, that has been developed in the meanwhile by Nikos Tanzalis. This is a great tool, it's amazing. And also, we tried to run this study on a large scale. So we took the 3 systems that were used in the original study, and we also added on top 100 new systems. And finally, we performed a detailed qualitative analysis that was completely missing in the original study. Okay, so these were the main changes. Now, this was instead the main research question of the original study. Are refactoring-related commits more likely to introduce bugs, basically, than other commits? Okay. Now, before answering this question, what we had to do was to select the 100 additional systems that we wanted to use, right? How do you do in this case? Well, what we did was, let's go to GitHub, let's apply some selection criteria typical of MSR studies, and let's use the systems. So what we did was to say, okay, we want to focus on popular and large projects from GitHub. So let's exclude forks, let's exclude tutorials, and let's exclude personal toy projects by applying these criteria. Like we exclude anything that has less than 100 issues, less than 1,000 comments, okay? Now, if you look at MSR studies, most of them apply similar selection criteria, okay? Of course, they can have different thresholds, but this is mostly what is done in the literature. And we found more or less 2,500 systems. These are all Java systems, okay? However, we realized that if we wanted to conduct our study in a reliable way this time, right, by controlling as many things as possible, we had to make sure that for the 100 systems that we were going to pick from this 2,500, we must have a way to identify in a reliable way the bug fixing commits, because these were basically the main pieces of our study. We needed bug fixing commits in order to provide them as input to the SSF and to get as output the commits in which a bug has been likely introduced, right? So what we did was to say, okay, let's manually analyze these 2,500 projects. And what we can do is to basically check if each of these repositories first of all, uses a clear label in the issue tracker to say this issue is a bug. And second, they consistently use a mechanism to link commits and issues so that we can say, okay, this commit fixes this bug, okay? So we started this manual analysis, and after we analyzed the first 1,000, we found out that less than 30, if I'm not wrong, 27, met our criteria. So they used the bug label in the issue tracker, and they had a consistent mechanism to link commits and issues. For example, they were mentioning the issue ID in the commit note. And we also noticed that most of these projects were actually run by the Apache Software Foundation. Now, I want to spend just 30 seconds on this slide just to highlight something that we applied a quite strict selection criteria for these projects, like at least 100 issues and 1,000 commits. So this is what is done in the literature mostly. But still, when we looked at these projects, we noticed that they didn't have the data needed to answer our research question. So I'll be back to this point, okay? But keep that in mind. So what we decided to do was to go for a plan B. And what we did was basically take all the projects managed by the Apache Software Foundation on GitHub, all the Java ones, manually look at them and selecting 100 from this set that were consistently using mechanism for linking and label in the issue tracker, okay? So we selected 100 systems from the Apache Software Foundation. Then we ran the study. We basically replicated the original study on the same 3 systems used in SCAM 2012, and then also on these 100 new systems, to answer the main research question, right? Whether refactoring tend to introduce bugs more often than other changes. And what we found was that this is actually true. So we confirmed that the original findings. We found that commits implementing refactorings have higher chances of introducing bugs. And we also confirmed that certain refactorings, like for example, the ones dealing with inheritance, are more likely to introduce bugs than other refactorings. So we were quite surprised because basically we applied a completely different experimental design on a much larger sample of projects. And we, of course, had the different numbers, right? But we basically confirmed the main findings of our original work. However, in this replication, we also had a very detailed qualitative analysis, as I said, in our RQ4. We phrased the RQ4 as to what extent does refactoring actually trigger bug fixing activities. So what we did was to take from our dataset the commits that, accordingly to our quantitative analysis, had a refactoring introducing a bug, and we extracted from it a sample for manual analysis. So we extracted 384 commits that, accordingly to our study, had a refactoring introducing a bug, okay? And we manually looked at these 384 commits. We had 2 evaluators per commit, a third evaluator in case of conflict. And the whole point was to check whether the refactoring in that commit was actually responsible for the bug introduction. Because this is basically what the SSZ algorithm was telling us, right? So what we found was that only in 38% of the instances in our dataset, the refactoring was actually responsible for the bug introduction. In the remaining 62% of cases, the refactoring was unrelated to the bug introduction. The bug, for example, was already there before that commit, or was introduced in that commit, but not due to changes related to the refactoring. So basically, in this qualitative analysis in RQ4, we confirmed the possible role played by refactoring in bug introduction, because we still had 38% of commits in which a bug was introduced due to the refactoring, but we partially debunked the findings of our quantitative analysis, because we know that in our quantitative analysis, there is the risk that we have something like 60% of noise, okay? Of course, we have this for the refactoring related commits and also for other types of commits with which we compare, but you understand that here the qualitative analysis gives you a completely different view on what we found in the quantitative study. So what I learned from this replication, basically, a couple of things that I think are very important. First, that mining thousands of repositories is super easy nowadays, but getting clean data is not. And what I mean is that despite the fact that we applied very strict rules, I think, for the project selection, still we didn't have the data to answer our research question in a clean way, because most of the projects were not labeling their issues in the issue tracker, were not linking commits closing issues, and so on, right? So I think now when I need to run a study, even if it's of thousands of repositories, I always have nightmares like, I want to check whether the data needed for my research questions are there or not. And this is something that I strongly recommend all of you to do. And the second that I think is quite obvious, but I think it's strongly highlighted by this experience, is that quantitative research, especially when we are talking about code quality, is not enough. And I think this is something that we can learn from this study, but also from the first story that I told you, right? Because I was basically evaluating the quality of the recommendations of my approach by using some quantitative metrics, but we have seen that this is not enough if you want to know something about the quality of the recommended factories. You need feedback from developers, right? So I think this point is extremely important when talking about code quality, because code quality is something that is not really objective, right? There is some sort of subjectiveness there. This is why you need qualitative analysis. And I also want to close this second part with a paper, as I did for the first part, because also in this case, I think that as a community, we are moving in the right direction. And I just want to point you to a single paper that is this one, Why We Refactor Confessions of GitHub Contributors. This is probably my favorite paper about refactoring in the last few years. And the qualitative analysis that the authors perform, I think is really inspiring, at least it was for me. So if you're working in this area, I recommend you to read this paper, because what the authors did, it's amazing in terms of getting qualitative feedback. And it's a very, very nice experimental design. Okay, so the last part of my keynote, this one will be short, don't worry, because I promised to stay in 35 minutes. It's about future research directions, okay? And in particular, I want to tell you a little bit about what we are doing in my research group. And again, these are things that we are investigating right now. I mean, I don't have any publication on these things. We are working on mainly on this project that has been funded by the European Research Council. And the goal is basically to build, let's say, the next generation of recommender systems for software developers. And I will tell you 3 research directions that we are investigating, just with the hope that you can get some good ideas out of them. Okay, I don't even know if they are good research directions yet. So the first one is partially automating code review. And I want to stress the partially here, because we know very well from the literature that the goal of code review is not only to improve code quality, right? It's also to basically transfer knowledge between developers. So you don't want to have code review completely automated. Does not make sense. But what we believe is that if you look at code review repositories, for example, in pull requests, or there is Garrett, right? There is a lot of data from which we can learn how we can automatically perform some of the tasks that are usually performed in a code review process. Because we have the code submitted for review, we have the code recommended, the revised code recommended by reviewers, and we have all the discussion between reviewers and the contributor. And what we are trying to understand is if we can learn from certain patterns, how we can, for example, automatically suggest a revised code when the developer submits a code with a pull request, so that we can do an automatic check and say, look, that in most of the cases when you have these coding patterns, the reviewers of this project recommend to implement this code change. Again, small things. I don't think we can automate everything. The second is documenting the rationale for quality improvement. This, I think, is one of the weak points of most recommender systems in the field of code quality. What I mean is that they recommend a solution, like a refactoring solution, but they are not able to explain why that code change is needed. Okay, what is the rationale for that code change? And what we are doing right now is basically to mine sources where you can find unstructured data, to build a knowledge base where you have pairs, let's say, of a code change implemented by developers, and then a short natural language text that explains the rationale for that change. Because in this way, if we are able to build a large knowledge base with this rationale, we can basically in future try to learn how to justify, how to motivate a code change that is recommended by an automated tool. Third and last is customization of code quality recommendations. And what I mean with that is that we are trying to profile the coding style of software developers. What I mean with that is that what we noticed is that different developers and different projects even more have different coding styles, different preferences in terms of code quality. As I said before, this is quite subjective from many perspectives. And so we believe that when a tool produces a recommendation, this recommendation is not valid for all projects or for all developers, but must be customized based on the specific consumer of that recommendation, so the developer who is receiving that recommendation, right? And again, this is something that we are investigating, how we can infer what are the coding preferences of projects or of specific developers, which is even a little bit more challenging, I think. So with this part, I would like to conclude my keynote. I think I'm perfectly on time. Just one time to wrap up. So what we have seen is basically a short story about the empirical validation of tools to automatically improve code quality. And I think the main message that I wanted to give there is that it's fine if you try to do something different as compared to what is done, even in papers published in top venues, because as a community, we are trying to grow, okay? And how do we grow? Well, by exploring new things, right? By trying to improve each other's work, basically. And then I told you the story of what I learned by replicating a work that I did almost 10 years ago. And basically that we have seen how easy it is to find a lot of data, but how difficult it is to get clean data. And also we have seen that only qualitative analysis can tell you how to read your quantitative data about code quality. So it's important to always combine the two. And finally, I try to give you some pointers for research, for future research, I hope. But I think the single important message that I wanted to convey with this keynote, especially to young researchers, is to always try to target excellence, not in terms of research output, but in terms of how proud you are of the research that you do, okay, of what you're submitting, basically. And also, I think we have seen that as a community, we are going in, I think, in the right direction, especially in this field of code quality. But it's up basically to you and to the future PhD students to further improve what we did in the last years and what we are doing right now. Thank you very much, and thanks for attending my talk. I'm ready to answer your questions.
Thank you very much, Gabriele, for the very inspiring keynotes. I think it's not only a keynote for young researcher. I think most of the things you mentioned resonate with pretty much everyone in this space, I think, empirical software engineering things. And I pretty much agree with more of it. But yeah, I hope we can have some question. So we have time for some question now. So if you have a question, please either write it here in the chat or on Discord, and then we'll convey it here. But just maybe to kickstart the discussion, maybe I will shoot one, right? So we'll start get going. So I'm fully agree with the need for qualitative studies. I think we really need to look at the artifacts and try to make sense of what we're counting or inferring and so on. But one thing you mentioned, it's about the needs to go back to developer and get their feedback, right? So I would try to be a bit controversial on this. What will you say to people who will question the validity of developer as the gold standard here? Because of course, not all developers are good developers. Not all developers knows what is necessary, the best design, the best approach for their system. They also write crappy code. So how do we clean out the noise in this feedback that we get from developers, right? Like what's your thought on this? I think it's even more pronounced when you build a recommendation system and say, okay, we will mine what developers have produced as rational for what they have been doing, and then we will recommend based on that, right? But a lot of things they are doing are wrong, right? That's why the software is buggy sometimes, right? So what will you answer to that?
So I completely agree with this point, but let me tell you something. So first of all, something that I think is very useful is to get feedback about, let's say, some recommendations that you produce, since we are talking about that, right? At least for now. Both from developers that developed that system and also from other developers on that same system, even developers who were not involved in the development of that project. Because in this way, you can avoid the issue of developers who are the owner of the code that, for example, you're recommending to refactor, and they say, no, wait a second, the code that I wrote is perfect, because this could be a feedback that you get, right? So I think if you have both points of view, I think that this could help at least to address a little bit this threat to validity. And the other point is that when you get a lot of feedback, and this is not easy, by the way, because usually you can get feedback for, I don't know, 10, 20, 30 developers, but not really hundreds, right? That's difficult usually. I think what is important is that you anonymize that feedback and make it available to reviewers or to other researchers. But then I think it's also up to the researchers to say, I don't think that this comment makes sense. I'm not going to report it in the paper, because if all the comments are there, I think everyone can check. But what I think is important is that you report the ones that you consider valid as both positive and negative comments about your recommendation. So I agree with you. Also, this evaluation is not perfect because you will get some noise, but I think it's up to them, to the subjectivity of the researcher, or even better, of all the authors, to understand what are the feedback from which they believe we can learn something. And when I say we can learn something, is basically in which scenario your approach works, in which scenario your approach does not work, and how it can be improved. So yeah, I agree with you, but I think it's a matter of taking the best out of this feedback that you get.
Okay, thanks for the great feedback. I think we hit it up. We started having questions coming in. So we have a question from Shidra, which where and how do we draw the line for the number of projects when we're doing quantitative studies, or the number of developers when we're doing qualitative studies? Like, how do you, from your experience, how should people go about this?
Yeah, that's a good question that does not have a good answer. But the point is that what I try to do at least is to first of all, I look at the literature to try to understand what is the standard, right? At least in general. So you want to do a paper on refactoring, try to have a look at the literature to see how many projects in recent papers have been used. They could be in the tens, in the 100s, in the 1000s, and then at least you get an idea of what the community standards are in that moment. But this does not mean that this is what you have to do, because sometimes there are certain analyses, especially if you want your paper to be highly, let's say, on the qualitative side, right, on the qualitative analysis, that cannot scale. I mean, now I'm working on a paper with one of my students that is again about code quality in some way. And we realized that to run the tool that she's developing basically on one system, we probably need 10 days because we need to customize the project because it's something that is a little bit complex. And I think it's perfectly fine if you explain in the paper and say, look, running this thing takes 10 days. If I want to do this for 10 systems, it takes 3 months, okay? And then I think if you explain all the process that is behind the work that you did, and you can justify the fact that you only have 10 projects because anyway you worked on this validation, 3 months is perfectly fine. So the guideline that usually I give to my PhD students is if everything can be automated and there is no reason for saying, okay, I want to do 10 and not 100, then try to target a large number of systems. But if you realize that there is manual work, that there are steps that cannot be automated, just select the good projects, make sure that you have good projects, and just analyze a number of systems that make sense to you in terms of effort that you want to put. Because of course, you can work 3 months on the validation, you can work 3 years, but there is a limit, right?
Yeah. So the next question, it's from Professor Adams. It's a very practical question. Based on your experience, how do you motivate the use of students in your user studies that you report in your papers?
Okay, so yeah, thank Bram for the question. So first of all, I think I'm not running studies with the students since a few years. And it's mostly due to the fact that in universities where I moved, it's a little bit complex, okay? So I prefer just to try to get feedback from developers if I manage, even if, of course, I'm able maybe to get feedback from 10 developers versus maybe 50 students, right? But I think in terms of motivation, it's important that you explain what are the skills needed by the participants for that study. And if the skills needed by the participants for that study are part of the basically student skill and you can motivate that in some way, I think this is a good strategy. Like you say, look, they need to be expert in object-oriented design, but they took this course, this master course the last year, or they are taking this course this year. I think this is something that can help in justifying, but this does not mean, of course, that you will not get the usual reviewer complaining about you use students in your study. So it's something that I would recommend, but it's not a bulletproof recommendation.
Okay, good. Let's make this a bit more lively. We have more questions. Then I think I would invite people to speak around, turn on their camera so that we get more interaction, I think. So Andrea has a practical question. Andrea, maybe you want to speak up? Yes.
Okay, hi. My questions also involves using master students. So not only using master students to do the replication or the studies, but involve them in doing the research. So like helping you to do the research, involve them in making the research.
So you want to do how this can be fostered, basically? How to do that?
Yeah, how can you do that together with the master students? So I don't have yet PhD students, but how to do the study with the master students.
So with the master students running the study.
Yeah. How to involve them in the study to become a master PhD student.
Yes. So I think it depends a lot from the university where you are, and what I mean is that if the study program in which they are enrolled foresees a master thesis that is substantial, like for example, it's, I don't know, one full semester, or anyway it takes a substantial amount of time, I think that is a good strategy. So what I usually do is to try a little bit to advertise the research that I do in the master courses, explaining them, look, if you want to do research in this field, you can come and talk for a master thesis with me. And then the master thesis is basically a research project that I think can be done in the amount of time that I have available. It could be, again, I think in our case is 600 hours, more or less, the effort that is expected for a master thesis. So you plan accordingly to that. And in some cases, you can get a paper out of it. In some other cases, no. But I think what I also think it's a good idea is to explore with master students research topics that are a little bit risky, meaning that are likely to fail. Because anyway, they will get a master thesis out of that, but maybe you don't get a paper because you realize that the idea that you had does not work. But still, this is a good research experience and you can learn that this is not a good direction, right? And then you can explore other research directions, but at least you didn't have a PhD investing 6 months on that idea that didn't work, that could be more frustrating for a PhD student than for a master student. And anyway, from the master student point of view, again, you can write a master thesis on negative results. And if the student is interested, can continue the PhD by exploring other ideas that maybe work better.
Okay, thank you. Gemma, maybe you want to just live your questions.
First of all, I really enjoyed your keynote and especially your takeaway messages from each of the part. So my question is how your advice can be applied in the context of machine learning studies, because, for example, now it is a common habit to mine several repositories and and then I will run my machine learning model and I construct a change prediction model. So my question is, how can we go out from this loop, from this study, and where and how we can improve the quality of this work?
Okay, so if I got your question, basically what you're saying is when you train a machine learning models, you mostly rely on a lot of data and you get this sort of black box. Then this black box gives you some sort of recommendations, how to understand if they are valuable or not.
Yes, and how your advice can be applied in this context, because I think that also you read, I think that you read a lot of papers that do it like this. I mean, I have this data and then I run and construct this model.
So there are two things. The first one is, I think it's related to what I did, and is making sure that you have the data to train your model. And what I mean is not about the quantity of data, but the quality. Because again, it's easy to mine a lot, but then are you really training the model for what you want the model to learn, right? So this is the first part, and it's not trivial, because if you're going, especially with deep learning models, you can have thousands of entries, and you need in some way to make sure that they are clean. For what concerns, once you get the recommendation, I think what is important is, as I said, to not rely only on quantitative indicators, which means once you get some recommendations, try to understand whether they would make sense from a developer point of view. And this does not mean only talking to developers, but it could also mean that you try to simulate what would happen in the change history of a system. Let me give you a concrete example. Let's assume that you develop with machine learning a tool that can recommend to the developer what is the next method to run, okay? So it reads the methods written in the last, I don't know, 5 minutes, and then it says, okay, now probably you want to implement this method. What you can do is to take a part of the history, look at each commit, decompose this commit, for example, and say, okay, I take 90% of the commit. I assume that this code has been written, and I see if my approach can recommend the remaining 10%. Since you're using real data, to a certain extent, you can say, look, in this context, probably my approach would have saved a certain amount of effort to developers because 20% of the methods could be generated automatically. So I think it's important that you try to use data that is meaningful for what you want to demonstrate. And this, I think, applies to any context, to any sort of machine learner you're developing.
Thank you, Gabriele.
And maybe I'll jump on that. So what do you think of the trends of moving to a more complex and advanced machine learning models? What's your thought on this? Do you think it's the right trend to go, follow the next neural network models? What do you think? Okay,
so I think what is wrong is to, especially from the PhD student's perspective, is to say, I learned how to use this model. That is, as you said, maybe the latest one that has been invented, whatever. And then you say, now I think to all possible problems that I can solve with this model. I think this is a very bad pattern for a PhD. Instead, I think it's perfectly fine if you have a problem And then you say, okay, one of the ways in which I can solve it is maybe through this latest approach that has been proposed. But then what is important is that you also have a very simple baseline. Because if you want to go with the most complex neural network that is out there, at least you need to demonstrate that all the effort done in terms of training, in terms of hyperparameter tuning is worth it. And again, if you show me a paper in which you say the Bleo score is 2% higher, I don't know what it means. I don't know what is the added value of that finding. So I think it's fine, but it must be justified. And again, from the PhD student perspective, should not be like, okay, my ideas are, let's apply this model to everything I can, because that I don't think can lead to a coherent and well-structured PhD in the long run.
Yeah. And the rationale, right? Because some of those models are hard to explain anyway. So yes, it's harder to know the rationale behind things.
Yes, that's a good point.
So Shrida had some interesting question about the metrics. So early in your keynote, you mentioned that it was standard practice in our field. I myself, I did that many times where we assess things by using metrics, right? Because it's cheaper and
yes,
it used to work in the past, right?
Yes.
So do you, what's your thought on this? Do you think we should totally move away from that? And if we can still use some of the metrics, which metric to pick? So Shranda, maybe you want to share your thoughts, maybe just open your camera and then, so you had 2 or 3 questions around this. So I thought maybe nice if you can interact. Shrida?
Well, I can answer anyway.
Okay, can you hear me now?
Yes.
Yes.
Yeah, okay, yeah. Thanks for a interesting talk, Gabriela. So a couple of questions I had was one on if you look at metrics, especially for code quality, like there is a survey paper which lists around 250 odd metrics, and there are so many textbooks. Now, what happens is when my students go around and then they start saying that okay, we propose a better technique, then I would say like okay, let's pick up. We start with CK metrics and then move on to other sort of metrics. And whatever metrics that we choose, reviewer comes back and says like, why don't you use that metric, even though we have the justification? So this is one question, like, how do you go about choosing the right sort of metrics? That's one question. And shall I also ask the next question?
Yes, please. I think you had a couple of.
So let me answer this one. Otherwise,
maybe you can quickly answer this and then I'll ask the next.
Then I'll get to the next one. So for this one, I agree. I mean, there is no easy choice of the metrics. Something that I recommend to do is, first of all, try to understand what you want to evaluate. For example, code quality. If you know that you are particularly interested in complexity, of course, you know that you have to focus on certain metrics. Then among the complexity metrics, let's say, or among the cohesion metrics, which ones to pick? What I do usually is, let's try. So one good guideline is try to compute the metric on a set of classes. In this case, if it's about class cohesion, it could be a set of, 1,000 classes that you take from some systems, and try to run a PCA analysis. See the ones that capture different components, report this analysis in the paper, and you say, based on the PCA analysis, I know that the C3 metric captures something different as compared to the LCOM metric. So I'm using both metrics because they can provide different indications. So this is what I would do. And concerning, I think Fuchs was saying whether it's still good to use quality metrics. Absolutely, yes. I was not saying that. I think it's also good when you compare different approaches because it's very objective. But what I was saying is that alone is not enough because it just tells you part of the story. It's just that. But combining quality metrics analysis with other more qualitative analysis, I think is perfectly fine.
Perfect. Yeah, just a quick question on the same thing.
Yes, maybe you want last.
Yeah. So the question is like, what is happening? I mean, like, when we start doing this empirical study, we start looking at MZ, TSC, and so on. So the students come back and say like, okay, here is an empirical study which was done on 3 projects, okay, 3 big projects, and then say like, okay, that's a well accepted and well cited paper. Now there is another paper which says that which let's say does the empirical study on 154 projects, some number, okay, some big number. It can go 2,000 also. Now the challenge that we are facing, like I realize that at least now with the way the community is going, there is definite need for both quantitative as well as qualitative. I can't just say like, okay, I just crunch these numbers. I may have to do, you know, the qualitative evaluation with developers as well, right? So even when it comes to developers, there'll be a study which is done with, let's say, 14 developers. There's another study which has qualitative done, with 24 developers. And unfortunately, I'm finding, and my students are finding that, in the literature, we have all the examples. There's a paper which is done on 3 projects with 10 developers. There's a paper which is done on 50 projects, let's say, with 20 developers.
Mm-hmm.
Now, the challenge is like, how do we kind of like, of course, like we kind of decide, we have some rationale for it, but the insights that we are writing in the paper they keep differing depending on the number of projects. If I'm drawing insights from 3 projects, my confidence level in terms of the insights is maybe a bit less. So the reviewer keeps asking, or they keep saying that, okay, why only 5 projects? Why not do 10? Why not do 15? So how do you think you face this kind of? How do you think we could address this kind of challenge?
Okay, yes. I think this is kind of related to to one of the questions that I got before about how you define the number of projects, basically, right? Or the number of developers in this case. So for what concerns the number of projects, I still think that it really depends on the analysis that you do. If it's something completely automated, cheap to run, difficult to justify that you only have 5 systems nowadays, because the standards in the community are not these ones, especially in the MSR community, okay? And I'm not saying it's correct, it's wrong, we should accept with 5 systems, with 10 systems. There is no guideline, right? So it's difficult to say, yes, 10 systems are enough, because it also depends on the research question. If you're trying to investigate something that is very specific, for example, and you have a very homogeneous set of systems, then it's difficult to say, yes, what I'm saying does also generalize to other systems, because those systems are very similar between them. So there is also a matter of how different are the different subject systems that you are using. So again, my recommendation is, if it's completely automated, try to improve this a little bit and have a look at the literature, look at the upper bound or the lower bound, and try to be in that range. For what concerns the developers, so I have many papers with very few developers involved, like 5 or 10, very few. And I think what is the important thing to convince the reviewers that this is not a problem is the type of claim that you do based on the number of developers that you have. I mean, if you have 5 developers, it must be very clear in the paper that this is a very subjective feedback that you have for 5 developers. So sometimes what I do is to report, for example, the interview that I had with 5 developers in, I don't know, in 3 pages. So it's a lot, right? But it makes clear that it's very qualitative feedback that I try to get to understand the future research directions, for example, maybe. And again, then the reviewer can say, no, 5 is not enough, but it's important that your claims are aligned with the evidence that you have. And I think this helps a lot.
Yeah, totally agree with that. I think we have to disclose all the context in which the results are extracted, right? And so that people should interpret your finding by considering that specific context. I think that's, in my opinion, that's what's more important.
Yeah, I agree.
Thanks a lot for the great keynote and a great interaction. We are like way over time, so I think we can go further because there won't be any break. So thank you very much, Gabriele, for making yourself available and for giving this fantastic keynote. Thank you everyone for turning on your cameras and asking questions. I hope we'll keep this momentum through the day. And with that, we are going to a short break. Thank you.
Thank you.
And thank you again.